Okay, in this episode, we are going to build our first device sensor controlled instrument. It won't be amazing music, but it will be a nice, well, a sound at least. So, all right, we're starting here with the example. You find the link below the video. I call it Device Orientation Simple. And this is the audio XML file where we build the configuration for the application. And it's one element here, one audio node called oscillator node. That's a part of Web Audio API, and it's a simple oscillator that can make different waveforms. The only attribute I use for this one is frequency. So just so you understand, if I say frequency equals, let's say 220, and I save it and try the application and click here, you should hear a sound. This happens to be the sound of a sine wave with the frequency of 220 Hertz. So if I type 440 and hit play, that's an octave higher than 220, and that's how music works, or sound. Okay, it's not that amazing to have one pitch playing all the time. So what we want to do is to connect the frequency to be controlled by a sensor. And excuse me. The smartphone is now has really amazing sensors actually to capture the different movements around different axes. And through this tutorial we will try out different aspect of this. All right, so I want to connect it to something called Device Orientation Alpha. That is the angle of the smartphone on this axis. So it's pretty much like a compass, so like north, south and stuff. But remember, it's not north and south. It's totally local. So it depends on how you actually hold it when you initialize the application. That would be 0, I think. Okay. Next step to make this work is to have a mapping feature to map the data from the orientation change to something useful in terms of frequency range. And in this example, I have created such a mapper. I call them VAR, as in variable. So it's a placeholder for a value that will update continuously depending on the rotation of the smartphone. So how do we do that? Well, we give the variable a name like that, and I call it P as in pitch. And then I need to tell where shall it take its value from. And this variable should read its value from Device Orientation Alpha. And this is how I just decided to write it. So live with that. There are also Device Orientation Beta and Device Orientation Gamma, which is the different axes. So this is beta, and that is gamma, and this is alpha. Okay, and these variables, they go between different numbers. So typically the alpha goes between 0 and 360, which is one full lap around itself, around the axis. In this example, I tell the code that I'm just interested in, excuse me, the values between 0 and 180. That means that I have a range which is 180 degrees. So I just ignore the data in the rest of the circle, so to say. So I now create a setting where I can control the pitch using half of a circle. And next step is to map the incoming values, and they will be, remember, between 0 and 180, and they will be updated all the time. I think it's something like 60 times a second or something like that. So they will continuously be mapped to, I call it an outgoing value or a map out. And this value, the result of that process, will be stored in this variable object. So I say map out equals 220, comma 440. Okay, so then we need to talk about mapping. So these two sets of values, map in and map out, they make the mathematical transformation of the values between 0 and 180 and map it so it will always be a value between 220 and 440. And so we understand if the angle is 0, that will map to 220 because that's the first number of the map in and the first number in map out. If the angle is 180, that will map to 440 because it's the second value in the map in and the second value in map out. If the angle is somewhere in between, there will be a correlated value interpolated between 220 and 440. And exactly how that is done is actually the artistic side of the whole project. So we will come back to that because that will very much control how your instrument will feel and work. Okay, so to make this variable now control the frequency of the oscillator, we need to not set the frequency to 440, which will be a static value, but rather using the variable we just created. So if I instead type $P, that will tell the system to use a variable instead of a fixed number. And that will be the variable P, and we use the $sign to indicate that it will use a variable. And because P is updated continuously when we move the mobile phone, the frequency of the oscillator will be updated accordingly between 220 and 440 Hertz. Okay, we share our application. We save it first, of course, and then we share it and share the full screen version, email it to yourself or whatever. And then we have it on our smartphone. And before we hit init sensors, I would recommend you to point it in a certain direction and be consistent and do that every time you init the sensors, because that's how they will relate to you and your position in the room and stuff. So I point it to the right now and hit init sensors. Okay, so there's a sound that goes between 220 Hertz and all the way up to 440. You hear this glitch here, and that's where the sensors is going from angle 0 to 360 degrees. So that will flip over to maximum from minimum. So maybe you find it more useful to use a range in between. So like 90 to 270. So let's see what happens then. I save, and then it's just to hit update on the smartphone. And we just try pointing to the right and hit init sensors. Okay, so now the playable area is to my left. So if I would like to play it pointing forward, I should obviously init my sensors pointing towards myself. So I will do that. Okay. So then the 0 point will be toward myself, and this will be that point where it jumps between the frequencies. Terrible sound. Okay, so what can we do with those values? Well, we can, for example, change. if we would like to go 2 octaves, we just change the top pitch to 880. Save and init the sensors. Sorry, we need to update here as well. Init sensors. Oops. So that was 2 octaves. And finally, I would like to turn it the other way around. So we have low pitches to the left and high pitches to the right. Then we can do 880, 220. So remember that the first incoming value will be mapped to the first outgoing value, and the second incoming will go to the second outgoing, and then it will be interpolated between those. And now when the big number is first, the high pitch will then be to the right, I think. Sorry. So we save and we update, point towards myself, hit init sensors. So now the high frequencies are to the left, no, sorry, to the right for me. I don't know about what about the camera and directions. So fiddle around with that and get used to using a variable that maps the incoming values to something useful. For the outgoings, it can control a frequency of an oscillator.